Alright guys, in this video we're going to do the calculation part of in finding equations of planes. So we already know that how the equation of how a planes look like, and now we are going to discuss on how to find the equations of that plane, and later I'm going to show you what is one of the use of that equation. Okay, now if you look at this, the two most important component for you to know before we can calculate get the equation is we need to have these two components, which is two vectors. So these vectors denoted as n here, it stands for the normal vector, where when you have it we will be able to determine the tiltness of that plane, because wherever this normal plane pointing out to, it will always show the 90 degree from the plane, okay, orthogonal. Okay, so and the other one will be the vector that is laying on that plane. So by using these two information, we should be able to find out the equations. Okay, now to find the equation, right, we are going to use this formula, right? This might seem a little bit unfamiliar, but it is actually this formula, right? One of the properties of a dot product, when you multiply between two dot product between two vectors and you get 0, it means that the angle between these two vectors is orthogonal, 90 degree. So we are going to make sure that the angle between the two product is 0, so that we will be able to get a 90 degree angle where it is where you can see this vector will really on the flat surface of that plane. That's why we are going to use this. So a dot b equals 0, or in our case it is p1 to p dot n equal to 0. So why we are using this notation instead of a and b? Okay, because first, and as we have already know, you should have two vector, but usually we just going to be given one vector, which is normal, or maybe you need to figure out one vector, which is normal, and then for the other vector, as we have discussed before, maybe they are just giving you the location or the point of one coordinate, which is this. I just imagine that you have one coordinate p, x, y, z, just like as we discussed before, where you have one normal vector to determine the tiltness of this plane, and you have another information of point A here, right? So basically you are not really having two vectors, you're just having one vector. So how do you find the equation? So to do that, we can't really get to do that. Actually, we need another point so that we can subtract it and get the vector, right? Remember, vector is the difference between two location, right? So however, we don't really have the second information here. We just have one point. So because of that, we will arbitrarily, or we just find some general coordinate, right? Coordinate that being represented generally x, y, and z, and subtract with our point. So that's why this n here, or in our case here, the b represent the normal vector, right? Where we know the value there. As for the first vector, we don't know the value, but we do know that the value should be the vector should be x1 x minus x1, right? P1 to P is P minus P1, right? So the vector of P1 to P is the value of P minus the value of P1. So x, we know that for x, for the vector of x is x minus x1. For the vector of y, y minus y1. For the vector of z, z minus z1. So that's why we are having this instead of a number, right? It is just in a general form. If we know the number, yes, of course we can subtract, but we actually don't know it, so we just arbitrarily put it like this. And for n here, we will have a value later, but for now we just put a, b, c. So now we have these two info. Just conduct the dot product, where you times and sum each component individually. So x1 minus x times with a, plus with y minus y1 times with b, plus with z minus z1 times with c, equal to 0. Alright, then we'll just expand it and classify it, so it will become like this. Okay, and this information in this bracket later will be solvable, because it will be in the form of numbers, so it will be in a form of value, and it is actually denoted by d in general. So basically, at the end, you can expect to get an equation for your plane in this form: ax plus by plus cz plus d equal to 0. Right? Don't fret just yet. Let's try to do it by using an example. Okay, now look at the first example. We have equation. Find the equation of plane that passes through this point. You have one point with a normal vector. Okay, so let me input that. Alright, so we have this point and we have this n, and I have inputted in the formula of dot product. So for the n, we able to substitute it directly because we know the vector, right? As for this vector, we don't know the vector, but we know the point. So we know that to get a vector, we should subtract this point to the other point that we don't know. So we'll just do p minus p1, or any value, right? So it is actually 2 minus x1, 3 minus y1, and negative 1 minus z1. So 2 is the x, 3 minus y, and negative 1 is z. So we'll just leave this like that, and then let's try to solve this to come up with an equation. Okay, I have do the calculation, but I need to be repeat a bit, right? I made a mistake just now because I mistakenly identify the p here as this p, but it's actually the p1. Right, so we have the normal vector, and we have the point p, which is, for this formula, it is a p1, which is this 2, 3, negative 1. To get this vector, we should subtract p to p1. So x minus 2, y minus 3, and z minus negative 1, which is become z plus 1. So this is the first vector, which is this one that we obtain based on the subtraction of p1 to p. This p here is any value, right? It can be any value. Wait a minute. Okay, it can be any value of x, y, and z. So to find a vector, we have to subtract between the two, right? So p minus p1, right? X minus 2, y minus 3, z minus negative 1, or plus 1. So you get the first vector. And the second vector is a normal vector, so we just input it like this, and then we find the dot product, which is by just multiply and sum, right? So x minus 2 times 5 plus y minus 3 times negative 1 plus z plus 1 times 2, and we expand it, and then we solve for the equation, and this is the equation for our plane based on the given info. Okay, so let's try to look at the plane just now. This is the given information, right? They give us the normal vector of 5, negative 1, 2, and the point of 2, 3, negative 1. Okay, what we did just now, we calculate this. We calculate the equation of this plane by using these two information. So what can be expected is that we can, given any two information of x and y, or x and z, or y and z, we able to figure out what will be the exact point of that of another unknown variable. So if given x and y, we'll be able to find the z, and if we try to look at it in a graph, it should be on this plane. Okay, for example, let's take let's try to calculate what if, okay, for example, let's say we want to, we know that the x is 1 and the y is 1, but so given the x and y is 1, what will be the z later, so that the point will be on this plane. Okay, so by using the equation that we obtained from that plane, just input x1, y1, and we're able to figure out that z should be 1 over 2. So if we input it in this plane, right, that 1 over 2 should be on this, yeah, it should be on this plane. Now you see E here, this is a point that we just calculate just now. Alright, let's try to not use another information. Let's say we want to find for maybe f equal to what will be the location, the value of z if the x is 4 and y is 5. Okay, so just input everything and you'll get z negative 5. So we know that if we to stay on that plane, when x is 4, y is 5, the z should be negative 5. And if you plot it in this chart, yes, you should get E there, the F here, right? This is where 4, 5, negative 5 is, basically on the plane. And you can imagine we can have a lot more different point here, right? And it can be, we can look it out by using the general equation that we just found. Okay, so that's it for this video. Thank you.